Dear friends, I myself, Dr. Bharat Parab, discussing the topic visualizing solid shapes, faces, edges, and vertices or vertex. Okay. Now consider these solids, three-dimensional structures. This is a cube, and this is a pyramid. Now this color part, red color, and this yellow is a face of pyramid, and this is the face of the cube. It has five more squared faces, and this has four more triangular faces. Okay, so these are called faces. Now these ends, lines, are called edges, and these are the vertices or singular, this is vertex. Okay, so we'll see here solid made up of polygonal region, any solid shape which has a polygonal region, either square or rectangle or any polygon or triangle. These are called the faces or face. It's single. Okay. Now faces meet at edge. This is a face. This is a face where they meet. This is called edge. Okay. And edges meet at point which are called vertices or vertex. This is the edge. This is the edge. They meet at this point which is called vertex. Okay. So such type of solids are called polyhedrons. Okay. Now we will see other part of the definition. Okay. That means polyhedrons have polygonal faces, okay, and not curves or round. That means shapes which have faces which are either curved or round are not polyhedrons. Okay. Try to understand this. Okay. So after having studied the definition of polyhedrons, we will see which are polyhedrons and which are not. Okay. So look at these figures. These all four. So if you apply the definition, you will see that these are polyhedrons. Okay. So now we will see which are not polyhedrons. Okay. Look at these figures. This is a sphere. This is a cylinder. This is a cone. Okay. These are not polyhedrons. Why? If you apply the definition, you will see that, see here, as sphere has curved surface, this has curved surface, while cylinder and cone has a lateral surface which is curved, yellow part. Okay, so this cannot be polyhedrons because it violates the definition of polyhedrons. Okay, so these are called non-polyhedrons. Okay, so again, polyhedrons are of two types, as convex polyhedrons and not convex polyhedrons. We will not call them as concave. We will call them, the nomenclature will be convex polyhedron and not convex polyhedrons. Okay. Now convex polyhedrons and not convex polyhedrons. Okay. Now this is a cube and this is some other structure. Both these are convex polyhedrons. Okay. Now, which are not convex polyhedrons? If you see the definition of convex and concave or not convex, okay, you can definitely understand this, that these are not convex polyhedrons. And if you have at least 2 points or at least one example in that figure, that if you join 2 points and if a part of the diagonal or joining line falls outside the main figure, then that cannot be convex. Okay, if you join this and this, whole diagonal falls out of this main figure, that is the red part, so this cannot be called as convex, so this is not convex. Okay, even here if we join this and this, okay, then some part of the diagonal falls outside the main figure, so that is also not convex. Still, if you get confused in this, write to me in the comment section and I will explain you the difference between convex or concave or not convex. But for this, we will be using only this nomenclature, convex polyhedron and not convex polyhedron. Okay. Now we will see the types of polyhedrons. The first one, regular polyhedrons. Okay. We will see the definition. Definition has two parts. We will see the first part. Polyhedron is called a regular polyhedron if its faces are made up of regular polygons. Okay. Now here are squares, maybe rectangles, maybe triangles like this, maybe combination of rectangle and square like that. Okay. So this is the first part of the definition, that polyhedron is called a regular polyhedron if its faces are made up of regular polygons. Okay. And second part is same number of faces meet at each vertex. So if you choose this vertex, now there are three faces meeting at this vertex. Okay. So like that, if there are three, then every vertex must have three. Here also three, here also three. You can see these three. And this is a triangle. So all are triangle. Okay. And if you choose any vertex, here there are three faces. Here also there are three faces meeting at this vertex. So this is a regular polyhedron and this also is a regular polyhedron. Okay. This will be clear if you see which is not a regular polyhedron. Okay. We are not calling it as irregular polyhedron, or we will call it as not a regular polyhedron. Okay. This is not a regular polyhedron because the expression is given here. Three edges meet at A. So if you see here A, there are three edges, one, two, another on back side. Okay. Three edges. Okay. But four edges meet at B. But here there are four edges, that means four faces. Okay. So this violates the rule, hence not a regular polyhedron. Okay. So try to study this, try to understand this. Okay. These are very easy definitions of these polyhedrons. Okay. The two important members of polyhedron family are prisms and pyramids. We will see one by one. First one, prisms. Okay. Look at these figures. This one and this one. These are prisms. Okay. We will see the definition of prism and see whether they fulfill the definition. Okay. A prism is a polyhedron whose base and top are congruent polygons. See, there are again two parts to this definition. Okay, we'll see the first part. A prism is a polyhedron whose base and top are congruent polygons. Okay, first of all, they should be polygons and they should be congruent, that is base and top. Look at this base, which is green. Okay, and this top for this. So these two are polygons and they are congruent. Okay, and we'll see for here this part, green part. Okay, and that part. Okay, this side and that side, they are congruent and they are regular polygons. Okay, so first half satisfies for both of these. Okay, and second one, and whose other faces, lateral faces, are parallelogram in shape. Okay, now you leave these two and these are parallelograms. Okay, and even here other faces are parallelograms. Got it? So go through this definition once again, try to understand this. Okay, I am reading it once again. A prism is a polyhedron whose base and top are congruent polygons, here green and opposite side, here green and opposite side, and whose other faces, that is pink, pink, here, pink, yellow, okay, pink and yellow, as in the above figures, are parallelograms in shape, okay. So this is the definition of prism, okay. Now prisms and pyramids are named after base, okay. That is, if the base is triangular, they are called triangular prism or triangular pyramid. Square, then square prism and pyramid. Rectangular prism or pyramid, like that, okay. And second one is the pyramids. Look at these figures, pyramids. Look at this and this, and we will read the definition. A pyramid is a polyhedron whose base is a polygon. Okay, here rectangle, here the triangle. Base is a polygon of any number of sides. This can have even more number of sides. Okay, and second part of the definition is whose lateral faces are triangles with common vertex. These these faces are triangles. Here see, with common vertex, okay. So what it says is, if we join all the corners of the polygon to a point not in its plane or outside the paper plane of the paper, we get model of pyramid, okay. Very simple, you can just think over it. It is very simple, okay. And this series last sentence, we have seen this earlier. Pyramids and prisms, or in this case prisms and pyramids, are named after its base. If base is triangle, then triangular, pyramid or prism, square, pyramid and prism, rectangular, prisms or pyramid, etc. Okay. Now we are heading towards a very important and very interesting part of this topic. You know, any polyhedron will have faces, number of faces, will have some vertices and edges. Now we will see the relation between this number of faces, number of vertices and edges. Okay. So read this. We now tabulate the number of faces, edges and vertices for the given polyhedron. Okay. Let faces be denoted by F, vertices be denoted by V, and edges be denoted by E. And look at this table. We have prepared this table. Okay. This is name of a polyhedron given. This is shape. Here, this is a face column, number of faces, number of vertices, number of edges, and this we will see afterwards. Okay. So see cuboid. This is a shape. How many faces does it have? 6. Okay. You can count. Vertices 8. 4 top, 4 bottom, 8. Edges 4 top, 4 bottom, 4 sides, 12. Okay. You can always count. Now this column is F plus V. This plus this, 6 plus 8 is 14, and last column will be edges plus 2, E plus 2. Okay. You can see, you must have got idea that F plus V is 14, E plus 2 is also 14. Okay. Very interesting point. We will now study for a triangular pyramid, then triangular prism, square pyramid, square prism. Okay. So this is a triangular pyramid. You can see this. Okay. Faces 4, can count. Vertices 4, 3 at the base and 1 here. Edges count 6. Okay. So F plus V is 4 plus 4 is 8, and edge is 6, 6 plus 2 is 8. Okay. Triangular prism, this is a prism, triangular prism. Faces 5. Okay, you can count. Vertices 6. Okay. You know, 3 this side, 3 that side. Okay. Edges count 9. 3 this side, 3 that side, and 3 here. Okay. Now f plus v, 5 plus 6 is 11, and e plus 2 is 11. Okay, can you see this? This is 14, 14, 8, 8, 11, 11. If you go ahead, this will be 10, 10, 14, 14. Okay, so we will see this square pyramid. Okay, faces 5, vertices 5, edges 8, count 4 at the base and 4 here. 5 plus 5 plus v is 5 plus 5 is 10, and e plus 2 is 8 plus 2 is 10 again. Okay, and square prism, you can see here, face is 6, vertex is 8, edge is 12, 6 plus 8 is 14, and 12 plus 2, e plus 2 is 14. Okay, so if you see a plus v is equal to e plus 2, you can see the comment here. You can see from the above table that f plus v is equal to e plus 2. This is for polyhedrons. Okay, so this relation is called as Euler's formula. Okay, so what we calculating was according to the Euler's formula. Okay, so remember this. This is very useful in solving some problems and understanding some polyhedrons. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of visualizing solid shapes and subtopic faces, edges, and vertices, let me know through comment section and I shall solve it. Okay, let us solve some problems on this topic in the next video. Thank you. Good luck.